Pleasant day and welcome back to Science 8 class tutorial. Again, this is me, Teacher Juna, and welcome to my virtual chemical laboratory. Now, let's go ahead and have a recap. In here, you are able to see a diagram wherein we have talked about particulate nature of matter. What I need you to do is to fill in the missing terms. Alright? I'm going to give you 30 seconds to do that. All you need to do is to pause this video for 30 seconds, and then once you're done, just play this video back. Okay? Alright, so now we're back and let's go ahead and check your answers. We have discussed previously about particulate nature of matter, and we talked about atoms, particles, molecules, which comprises matter. Matter has mass and volume, and it has 5 states or phases, which is solid, liquid, gas, plasma, and the BEC or Bose-Einstein condensate. Now, matter has 2 types of properties, which are physical property and the chemical property. The physical property has also intrinsic property and extrinsic property. Alright, so way to go. Good job, guys, for answering it perfectly. So let's go ahead, and I think you're ready for the lesson for this week. Now let's proceed. In here, we'll start with the first page of your self-learning kit, Science 8 Quarter 3, Weeks 3 to 4. The aim here is to help you explain physical changes in terms of arrangement and motion of atoms and molecules. Our main objectives is to define physical changes in matter, describe the arrangement and motion of atoms and molecules of matter during a physical change, and lastly, identify the types of physical changes in a given activity. Because our topic for this week is about the physical changes of matter. Now, I need you to prepare the needed things to use during our discussion. Again, please have your SLK with you, and then there are materials that you need to use for Activity 1 and Activity 2. It is listed and found in your SLK, and have your computer and printed ready with you as well. On the next page is the content map that shows an overview of phase changes. Right now, you are looking at a liquid being heated. This liquid is a water. Alright, so it has undergone phase changes or processes of boiling and evaporation. In this phase change, it is involving the intramolecular bonding, causing it to break. Why? The energy from the heat here, it has actually influenced and was absorbed by the liquid. It has changed its temperature, so from sliding past each other, it has vibrated more, and it tends to move faster than it was before. So here, if you can see, the forces are trying to break out from one another, as they are no longer sliding past each other, but they are trying to move faster. They are moving faster and faster because of the added energy. So these energy are the forces that is placing between the particles, and that is trying to break or helping the molecules to break away. And so the molecules has escaped, and since it has escaped, if you notice that the bonds inside the particles intramolecularly did not break, so there is still an intact composition of hydrogen and oxygen, which is water-based vapor. So from liquid, it has changed into a gas form, which is carried by the wind. Okay, so that is an overview. Right now, as we go along with the slides of this last video lessons, we are going to concentrate on the solid, liquid, and gas, the three phases of matter. Next, you are going to see content notes on your SLK, wherein we are going to define physical change. So, in definition, it is the process involving a substance change from one state to another. Now, as its characteristics remains intact, or the molecule stays the same even though there is energy or force is being applied. Alright, and then examples here, as we have talked on the previous slides, is the water and heat energy. It becomes a water vapor. And the next here, this is not an example of physical change. Remember, physical change alters the form of matter, but not the chemical composition. Now, what are the arrangement of molecules in a physical state of matter? So, if we must remember, this is the arrangement of solid, and then the liquid, and then gas. This was actually, we have discussed the arrangement of its molecules and of an atom of a certain substance. So here it is. With this next slide, you are able to see a phase change diagram. Now, in this diagram, you will see here the temperature, which is from the bottom to top, it is increasing. And here on the x-axis, you will see heat energy, which is from left to right, it is increasing. Now, we have here the solid, liquid, and gas, and the different phase changes, which are freezing, melting, and then condensation and vaporization. If you must notice on point A, which is on the solid, the substance is still on a solid form. It is below the temperature, or it has a lower temperature, and it has not received an additional heat energy. So the heat energy is low as well. So it is in a solid form. So the substance, always remember that low heat energy and low temperature, the substance is at a solid form. So it's remain intact. Okay. But when heat energy is added, and it will undergo melting, or for example, the solid that we're using is an ice cube. It has melted, undergo a melting process. It will turn into a liquid. So that will reach the C point. So this is the liquid point. And then when it has reached the boiling point, or the vaporization, because there is an added energy again, the liquid will turn into a gas. So it has become a water vapor and is carried by the wind. And then if the heat energy is lost, or if we have lost the heat energy and the temperature goes down, the gas will undergo condensation, and then it will return to its liquid form. Now, if this substance still loses heat energy and the temperature will go down, then it will undergo a freezing point, which will then turn the liquid into a solid form. So this is the phase change diagram of solid, liquid, and gas, and they are reversible. Okay, they are reversible. Next is how to identify the physical change. So always remember that physical change involves change in physical properties. So it means that it will undergo different phase transitions, and melting, freezing, evaporation, sublimation, deposition, condensation, and others. These are what we consider physical changes. The melting, freezing, evaporation, or boiling, sublimation, deposition, and condensation. This was discussed with you when you were on your 7th grade, right? And always remember that this is influenced and affected by heating and cooling. This is helped by changing the temperature of the substance or the matter. And then just take note here that you have to be careful though, because sometimes adding heat supplies energy for a chemical reaction to occur. Alright, and next is another phase transition is mixture. So in chemistry, components of a mixture retain their chemical identity. But sometimes you use caution because the general usage of the word mixture can sometimes include some chemical reaction. Alright? More phase transition like crystallization. Alright? And then allotrope changes. Okay? Magnetization and tempering. So if you can see here, all of this have changed its form, its color, but their chemical composition remains intact. So these are still examples of phase changes. And take note that some physical changes may be reversible, but others do not. However, reversibility usually indicates a physical change. Alright, so you need to remember that physical change, their appearance of matter changes, but its chemical composition remains the same. Okay, and the size, shape, state, or color of matter may change, but still the chemical composition remains the same. And on your SLK on page 3, here are some examples. And on the next slide, on page 4, here are more examples of physical changes. Okay. Now, physical changes involve states of matter and energy. As I've said, it will not undergo changes if there is no energy added to it or energy is taken away from it. So no new substance is created during a physical change, although the matter takes a different form. Okay, it could change in the size, the shape, the color of matter, but the physical change occurs when substances are mixed but don't chemically react. Now, a few Q&A questions here I would like to answer. Is there a change? Is the change reversible? To some, yes, but not all physical changes are easy to reverse. Then, was there a color change, or with exception, or bubble formation, or formation of a precipitate? Now, these are all signs of chemical change, not a physical change. Now, is there a chemical identity of the end product the same as it was before the change? So if it's still the same, yes, it is a physical change. But if the answer is no, then it's a chemical change. Now, physical change, these physical change are changes in which no bonds are broken or formed. Okay, no bonds are broken or formed. This means that the same types of compounds or elements that were there at the beginning of the change are there at the end of the change, because the ending materials are the same as the beginning materials. The properties such as the color, the boiling point, the size, etc. will also be the same. Physical changes involve moving molecules around but not changing them. So what are these types of physical change? This includes the changes of state. So here, so I have already discussed it with the phase diagram. So this is just another illustration, but still the solid, liquid, and gas form, they change state and they can be reversed. Okay, undergoing different phase processes like process in freezing process, melting process, evaporation process, condensation, deposition, and sublimation process. Alright, again, state changes of state are physical changes in matter. They are reversible changes that do not involve changes in matter's chemical makeup or properties. Common changes of state includes melting, freezing, sublimation, deposition, condensation, and vaporization. Okay, so what are other types of physical change? Could be the separation of mixture. Example here is decantation, filtration, manual separation, physical deformation like cutting, denting, stretching, making solutions on special kinds of mixtures, so selected. And then what do molecules do in a physical change? So what do molecules do? During a physical change, the arrangement of particles may change, but the mass, number of atoms, the number of molecules will stay the same. Physical change involve small changes in energy and are easily reversible. So a chemical change may involve a decomposition or synthesis reaction. So that's what makes it different from, or the difference between physical and chemical change. So how do we explain physical changes in terms of the arrangement and motion of atoms and molecules? So in here, as stated by Jonathan Butlick, which you are able to read on your SLK on page 5, a physical change could be done in a variety of ways. But one example and common physical change is melting and freezing. Okay, here. Now, when a substance is a solid, the arrangement of its atoms and molecules is tight and organized. The particles are not capable of sliding over and past each other or flying away from each other as they do in gases. When you melt a substance, you are more than likely adding thermal energy to it. So as the solid absorbs this thermal energy, the molecules begin vibrating more and moving farther and farther apart from one another. Their arrangement gets looser and looser until they are free enough to begin sliding past each other. The substance is now a liquid. Freezing reverses the process. The molecules become less energetic and more organized in the substance returns to being a solid form. In summary, a physical change causes the motion of the particles in the substance to change as well as the distance between the particles. Okay, so I have explained this arrangement of and motion of atoms while I was explaining the phase changes diagram. Okay, let's proceed. Alright, now on page 6, kindly answer activity 1. Kindly pause this video so that you can do the activity and fill out the answers on your answer sheet. Alright, next you are going to do activity 2, which will be your output. Alright, so you have to make your own collage. All you need to do is get examples or pictures or print pictures or cut out pictures of examples of physical changes. Alright, now the rating guide here for creativity is 15 points, neatness 10 points, attractiveness 10 points, accuracy is 15 points, a total of 50 points. Next is on page 8, 9, and 10. You are going to answer the evaluation. All you need to do is to pick out the correct letter and write it on the answer sheet. Alright, and then here are the references that is used to create this SLK. And for the assignment, you are to research about chemical changes in matter. So use these guide questions to answer your assignment. Next, we would like to acknowledge the author of this self-learning kit, weeks 3 to 4, which is prepared by Brenda C. Tan. Thank you so much for letting us use your SLK for this video lesson. And guys, once you are done answering activity 1 and activity 2, please don't forget to do the ClayGo, clean as you go. Alright? Okay, class, so thank you so much for watching this video lesson. I hope you learned a lot. And congratulations for completing the SLK on Science 8 Quarter 3, Week 3 and 4. Again, thank you and see you soon.